Welcome back. We are going to continue our fourth video. Man, already four. On the June 2016 Algebra 2 Common Core / Regents exam, we are going to begin with this part 4 video on the short answer questions. We will probably do 25 through 31, maybe, somewhere around there. And we'll stop, and then we'll do one more video after that. And that will be problems 32 through 37. And we will be done with one of the final exams, the videos for review. So let's, as we always do, start the part 2, the new section, by reading the directions, okay? Answer all 8 questions in this part. For each correct answer, you will receive 2 credits. Clearly indicate your necessary steps, including appropriate formulas, substitutions, diagrams, graphs, charts, etc. Utilize the information provided for each question, okay, to determine your answer. Note that diagrams are not necessarily drawn to scale. And for all questions in this part, a correct numerical answer with no work shown will only receive 1 point. All right, it doesn't matter if it's a 2-point question, a 4-point question, a 6-point question. If you have the answer with no work, you only get 1 point. So let's rev this baby up, vroom vroom, and get started. Number 25, solve for x. It seems like an Algebra 1 problem, but let's get a common denominator, shall we? If I have, 1 over x minus 1 over 3 equals negative 1 over 3x, okay? I want my denominators to be the same so I can combine them, all right? It seems like I have 3's and x's everywhere, so let's make all the denominators have a 3x. My fraction on the far left side here at 1 over x, it has the x, it doesn't have a 3. So if I multiply the bottom by 3, I have to multiply the top to keep that fraction the same value. All right? My middle fraction, 1/3, it has a 3 on the bottom, but it doesn't have an x. So if I multiply this bottom by x, I also got to multiply the top or the numerator by x to keep that balanced. And my fraction on the far right already has a 3x. So let's rewrite this. Let's multiply everything together and rewrite this. We've got 3 over 3x minus x, because 1 times x is x, over 3x equals negative 1 over 3x. When all your denominators are the same and you are adding and you are subtracting, badoosh, gone bye-bye. They don't matter. I just have this equation left. 3 minus x equals negative 1. And now it becomes very, very simple. All right? Let's subtract 3 from both sides. Negative x equals negative 4. And if I divide both of them by negative 1, my x should equal 4. Done and done. Simple and for easy. Easy. Number 26. Describe how a controlled experiment can be created to examine the effect of ingredient X in toothpaste. This is just common sense, okay? These first 2 questions, let me tell you what, are a breeze, all right? Let's look at this, okay? Describe how a controlled experiment, so an experiment that I can control, can be created to examine the effect of ingredient X in a toothpaste. Okay, so let's say I create, and I'm going to describe, so I'm going to write this. I'm going to create 2 groups. Okay. Group A will use, toothpaste is such a long word. Toothpaste with ingredient, sorry about my writing, X, and group B, my second group, okay, will use a toothpaste, long word, without ingredients. x. That's it. I create two groups. I give them both toothpaste. One group, group A, has this ingredient X in the toothpaste. The other group, group B, uses toothpaste that does not have the ingredient X in it. I mean, you don't got to write a 100-page thesis about, I've taken my data and I've gone to Harvard and Yale and we are analyzing the statistics. No, stop. Stop. How can this experiment be created? You just created it. I created two groups. One of them is using toothpaste that has an ingredient in it. The other group is using a toothpaste that does not have that ingredient in it. That's it. Done. 2 points. 27. Determine if x minus 5 is a factor of 2x cubed minus 4x squared minus 7x minus 10. Explain your answer. Okay, so we need to do work to show to get an answer, and then we got to explain it. Okay, there are two major ways, two obvious ways to determine if something is a factor of something else. And it has to do with division. Okay, now, when we divide, what tells me if something is a factor of something else? The remainder. If I can divide a number into a bigger number and get a remainder of 0, it is a factor. If my remainder is anything but 0, it is not a factor. What do I mean? 24. If I divide it by 6, it goes in 4 times evenly with a remainder of 0. Do you want to know why? Because 6 is a factor of 24. If I take 24 and divide it by 7, it goes in 3 times, but it also has a remainder of 3. 7 times 3 is 21. I subtract those, it's a remainder of 3. Do you want to know why there's a remainder that's not 0? Because 7 is not a factor. So determining whether something is a factor or not, we simply divide and look at the remainder. Now, that's one way. I said there's a second way, and there's an easy way to figure out the remainder without having to divide. That's using the remainder theorem. Okay? Now, some people are like, oh, yeah, I forgot that. That's fine. I would have divided Visca. I'll do both ways. Okay? I will do both ways. Let's do the obvious division. Okay? I'm going to divide x minus 5 into this right here. I'm not missing any terms. I have 3, 2, this exponent is 1. This doesn't have any variables. There we go. Not missing any terms. So if I take x and minus 5, because that's what's dividing in, I know this is too tall. All right? There are my 2 rows. But how many columns do I have? I start outputting every bottom corner. There's one corner, that should be 2x cubed. Here's another corner, that should be minus 4x squared. Okay, I have 2 more terms, don't I? Which means I need 2 more corners. So I'm going to create 2 lines to give me 2 corners. There's one right here. And here's one right here. Okay, so drawing those 2 lines give me 2 more corners, and I put my minus 7x, minus 10. All right, so let's do this. All right, how do I make, okay, this, again, let me remind you, this box should output 2x cubed. So this has to be 2x cubed, all right? What do I multiply x by to get 2x cubed? 2x squared times x. Now I can figure out what's in here. I can multiply my 2x squared times negative 5, get negative 10x squared. Again, all these should add up. These 2 should add up to negative 4. These 2 should add up to negative 7. And then we have my last one that should output a negative 10. If it does not, then we'll have a remainder and vice versa. Okay, if it does, then we don't have, well, the remainder is 0. Let me get into the terminology of saying we have a remainder or we don't in a minute, because that could be wrong. Right? So what do I add to negative 10 to get negative 4? I add a positive 6 x squareds. And what do I multiply by x to get 6x squared? A positive 6x. Now I can figure out this. I can multiply my 6x times negative 5. Ooh, I get negative 30x. And now I've got to look at my green diagonal. What do I add to negative 30 to get negative 7? I add 23x. Now that's a weird number. Well, let's go with it. Okay, so what do I multiply by x to get 23x? Just positive 23. Okay, this has no bearing on my answer. If I want to know if something is a factor, I got to look at my remainder. Okay, so what's 23 times negative 5? It's negative 115. Those do not match. So the remainder is not 0. So how do I get negative 115 to become negative 10? I add 105, and that's my remainder. Okay? So I know that x minus 5 is not a factor. My remainder is 105. All right? If my remainder would have been 0, okay, if I would have gotten a negative 10 here, okay, then I have 0 as my remainder, then it is a factor. Now, that's one way to do this, using division. And I don't mind if kids do that. It takes a little bit longer to do it this way than it does to do it this way. However, that reinforces the reverse tabular division, okay, which some kids need practice on and some kids get. Let's look at the remainder theorem. The remainder theorem tells me that, okay, now keep in mind, the remainder theorem, if you had to divide two things, oh, look at me reach for the highlighter again. The remainder theorem does not give you the actual quotient. The remainder theorem will only give you the remainder, okay? And in this case, it's not asking me for the answer to a division problem or the quotient. It is only asking me for the factor, which means I really only need to know the remainder, okay? So that's why I can use the remainder theorem. What the remainder theorem tells me is this. If I have 1x plus or minus something, okay, this is when it works the easiest. I take that, all right, and I add 5. I solve this like it's a booty cheek, so to speak, all right? I say x equals 5, okay? I take this 5 and I plug it into every x here, okay? And whatever that expression turns out to be is the remainder. So technically, since I did this already, and I know the remainder is 105, if I plug a 5 in here, I should get 105. All right, let's do this. 2 times 5 cubed. Okay, that's the first one. Minus 4 times 5 squared. That's the second one. Minus 7 times 5. This one. Minus 10. Okay, what does that equal? Well, you have a calculator. I mean, you could do that mentally, but you have a calculator. So, I mean, why would you is the question. On. Let's get out of here. And we got 2 times 5, that cubed. Okay, all the buttons pressed. Fantastic. Minus 4 times 5, beta squared. Super. Minus 7 times 5, beta, yeah. Minus 10. All right, so this should be 105. Ka-chow! And it is. Okay, now, what I have written here on the right side of this line, okay, what I have written here on the right side, this is fine. It equals 105. Look it. We knew that's what it should be. Okay? Now, I still need to get out of here. I still need to explain. Okay? Now, please, don't say it's not a factor because there is a remainder. For conversation's sake, if we would have had a remainder that was 0 and it was a factor, don't say it's a factor because there's no remainder. 0 does not mean no remainder. There's a remainder, it happens to be 0. Likewise, if you get 105, don't say it's a factor because there is a remainder. No, 0 is a remainder as well. Make sure you state what the remainder is. If something is not a factor, that means the remainder is not 0, and that's how you state it, okay? Or if something is a factor, you want to say that the remainder is 0. You don't want to say there's no remainder. Oh, it drives me crazy. So I say x minus 5 is a factor since, oh, yeah, I'll be okay. I'm in my little la-la land. I'm so upset with that explanation. So is not a factor since the remainder of 105 is not 0. Or you can say since the remainder is not 0. I mean, you really could just, since the remainder is not 0. Or you can say since the remainder is 105. But the connection there is the remainder is not 0. It's 105. 105 is not equal to 0. You need to write this. I hate that it makes you write for math, but this is where we're going, people. And I really shouldn't say I hate writing. All those subjects are nice. I'm just biased to math. Math is the best. Explain means you need to use words afterward. Now, if you were watching this, you might say, well, there's another way to do this. I can use synthetic division. I forgot about that. You can use synthetic division. I'll show you one more time. Why not? It might be really helpful. A lot of people that I show synthetic division to really prefer that over reverse tabular. But again, synthetic division only is, it should only be used when you have one x plus or minus 5, and that's what we have here. So what I do is I still solve for this booty cheek like I did here. So I'm going to take, okay, x would equal 5. If I T-bone this and booty cheek this, okay? If I have, this is one of my factors, and I have to solve it, and I say, okay, x equals 5. I take that 5, right? And then I take just the numbers, my 2, my -4, my -7, and my -10. All right? I take my 2, my -4, my -7, and -10. And I draw a line down here. I always drop the first number. I drop the deuce, no pun intended. That's a 2. And I multiply this number by whatever here to get my next number. 5 times 2 is 10. Okay? And I add everything. So I get 6. 5 times 6 is 30. I add everything, and I get 23. 5 times 23 is 115. And I add them, and that gives me 105. Okay, this is my remainder, the last number. Yeah, should be 105, shouldn't it? That's a lot easier than reverse tabular. But again, this has to be 1x plus or minus. Otherwise, it can be disastrous. All right? And so what would this be? This is my quotient. I have 23 0 x's, right? There's no x's here. That's a positive. These are all positive numbers. Okay? And then I have 6 x to the power of 1s plus 2 x to the power of 2s, and I keep on going. Okay, the next term will be x to the power of 3s or whatever. This was actually the quotient we didn't need, but synthetic division is awesome. I love it. I gave you 3 ways to do this problem. 2 of them were division, 2 different ways to do division. But I'm telling you, if you knew the remainder theorem, I think that was easy. I mean, some people might argue and say this is easier. Hey, whatever, go nuts. 28. On the axis below, graph one cycle of a cosine function with an amplitude of 3, a period of pi over 2, and a midline of y equals -1, passing through the point 0,2. Okay, you're graphing this. All right, so all the graphs on your test should be in pencil. Okay, so here's what we're going to do. The midline is y is -1. Here's a -1 on the y. This little dashed line is going to be my midline. When I'm all said and done, I'm going to erase that because I don't want to make it look like I have an asymptote or something. All right? And my graph. That's just for reference sake. Now, my amplitude is 3. That means from the midline, I've got to go up 3, 1, 2, 3, to 2, and down 3, to -4, okay? So my amplitude goes up 3 from the midline and down 3. Now, cosine is the cup. So my midline is going to be in the middle here somewhere. So I'm going to start way up high right here. And oh my God, that is perfect because that is the point 0,2. I wanted to go through that point. Now, keep in mind, everything in red is what you're going to end up keeping, okay? I could keep this number. I could keep the label, the numbers on the y-axis label, but everything else I really want to get rid of, okay, in green. And here's the last thing. My period is pi over 2. The period is the length of one cycle. So let's I don't know. Let's make this. I know I got to plot 5 points. I start here. I need 4 more points. I'm going to need a point here, 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 and here. So this is where I start. 1, 2, 3, 4. I'm just going to break that up into 4 equal sections. And I don't even have to label it. I just got to label the end. Okay? So let's go out every 2. So if I go out 2 to the right, okay, see I went 2 to the right, and that's my midline. Let's get rid of that without erasing anything. Boom. So I go out 2 here. Oh, look at me go. I just messed everything up. Okay, so I'm going to go out 2 on the x-axis, and I'm going to put my midline point. I'm going to go 2 more and do my low point. Go over 2 more to the right, I come back up. Go 2 more to the right, and then come all the way back up. So I just plotted these points. I just went out 2 spaces, 2, whatever. So now I connect this. And I just want to mark here. It's really important. The length of one period is pi over 2. I don't know what everything else is in between. I mean, I can figure it out, but why would I need it? So I want to get rid of everything here that's in green. There you go. So this is what it should look like. That is a perfect cosine curve, all right, that goes through the point 0, 2, has a midline of -1, okay, and ends, it has a period at pi over 2. The only thing you really need in your graph is what's written in red, all right? That is 100% exactly what they asked for. They didn't want you to keep on graphing it. They only told you 1 cycle. That's all you need. Don't do extra work. You ain't getting no bonus. On to the next one. A suburban high school, this is number 29, has a population of 1,376 students. The number of students who participate in sports is 649. The number of students who participate in music is 433. If the probability that a student participates in either sports or music is 974 out of 1376, what is the probability that a student participates in both sports and music? All right, when we did our last unit, I said independence shows its ugly head, and it did already once in a multiple choice question in here. All right, but I also said some other things you're going to have to know are given, and you're going to have to know this other equation with or. Okay, we have a probability of sports, and we have music. So if I want to know the probability of sports or music, that's like taking the probability of sports, adding it to the probability of music, and subtracting the probability of both sports and music. Okay? They are asking us, okay, well, first of all, let's see what they give us. They give us sports is 649. So I'm going to say out of my 1376, sports is 649 out of my 1376. All right. What else do they give us? They give us that music is 433. So I'm going to say, all right, here, that's 433 kids out of my 1376. All right. Then they say the probability that they participate in either sports or music, which is this one right here, is 974 out of 1376. They want us to figure out how many do both. Now remember, the very first problem we started with, if I'm adding and subtracting fractions and all the bottoms are the same, they're really insignificant. All right? So I really have this problem here. 974 equals 649 plus 433 plus, let's just call this x, this question mark. And it's really just simple algebra. If I add these two right here, I get 12, carry the 1, that's 8. That's 1,082 plus x equals, ooh, that's minus x. Look at me go. All right, that should be 974. So I'm going to subtract 1082 from both sides. And let's see, I now have extendo. These cancel. I have negative x equals, let me see, to get 1,000, that's going to be 26. 26 and 82, it's going to be 100, 108. I'm going to check myself. Turn that on. And I got 974 minus 1082. That's 108. All right. So I have negative 108. Of course, I want x, not negative x. So my x is 108. Okay. So I don't want to just say, okay, what is the probability that a student participates in both? This is the number that participate in both. They want the probability. The probability should be your initial fraction. The probability shouldn't be just a number. Weren't there 1,376 students? So out of those 1,376, 108 do both. This is the probability. This is the quantity of kids that are in both. This is the probability. Mister, do I need to make it a decimal? If it said round to the nearest 10th or 100th, I would make it a decimal. It does not. A probability can be a fraction. If I came up with a probability of 1/4, I can say the probability is 1/4 or 0.25. Both probabilities. If they ask me for a percent in this situation, it's 25%. Okay? So why would I do something that they're not asking me to do if I didn't have to? This is 110% correct. And it's an easy problem if you remember this. This was one of the three things. This, being able to find given, and being able to determine independence. And to determine independence, you either need to use this equation or know the given one. Okay? So pretty important. All right? Pretty good. All right, number 30, the directrix of a parabola. 12 times x plus 3 equals x minus 4 squared has the equation y equals negative 6. Find the coordinates of the focus. Okay, so I know if I have the directrix, which is negative 6, y equals negative 6, and I need to find the focus, I know one important thing about parabolas involving directrix, focus, and vertex. The vertex is always exactly in between the directrix and the focus, okay, vertically, up and down, okay? Now, maybe the directrix is above the vertex and the focus is below. That can happen, okay? But it doesn't matter if the focus is above or the directrix is above, and the directrix is below or the focus is below. The vertex is always in between, okay? So I have the directrix. Okay, let's take a look at this one for right here. I don't know, it might be the other one. But I have the directrix. They want me to find the focus. So if I can find the vertex, this becomes a really easy problem. And all I've got to do is set this into y equals format, and it will turn into the vertex form of a parabola where it actually gives me the vertex. Let me show you. Okay, I have 12 times y plus 3 equals x minus 4 squared. All right, I'm going to get rid of this 12. I'm going to multiply this by 1/12. Bang. I'm going to multiply this by 1/12. So right now, I have y plus 3 equals 1/12 x minus 4 squared. Resist the urge to FOIL this out and expand it and multiply the 1/12. Resist that urge, okay? Because you should know that there is a vertex form of a parabola that looks different than expanding it out and having x squared plus x plus a number. And that vertex form gives you the vertex, and that's what I need. If I have my directrix and vertex, I can easily find my focus. All right? So back to our problem. Last step to solve for y. So right now I have y equals 1/12 x minus 4 squared minus 3. FYI, the vertex form of equation is y equals a times x minus, is it h squared plus k? These two numbers give you the coordinate of the vertex. That's why it's called the vertex form. So let's take a look at this. These are two numbers. Okay, this is like the x and the y value. So my vertex is, okay, the y value is -3. That stays the same. If it's inside the parenthesis, you always flip the sign. So it's not -4. It's +4, -3. So we need to find the focus. All right, well, I'm a visual guy. So I'm going to sketch a little graph here. 1, 2, 3, 4. -1, -2, -3. Here is the vertex at 4, -3. The directrix is 3 below that. The directrix is that's the directrix, y equals -6, the directrix. That vertex is exactly in between. So if I got to go down 3 to get to the directrix, I should go up 3 to get my focus, which tells me my focus should be right here at 4, 0. So I will just write that right here. Focus is 4, 0. And that's what they want. They want the location of the focus, right? Let's go back. We got so excited. Yeah. Find the coordinates of the focus of the parabola. The coordinates are 4, 0. You are welcome. Number 31. All right. Look at okay. Let's take a look at number 31, and let's not overcomplicate it, okay? All these 2-point problems, okay? This you might have struggled with because of vertex form of a parabola. I get that, okay? I'll give you that one, okay? This one, if you knew this equation was easy, you were just solving for x once you got your probabilities. Easy if you knew what the heck you were doing. Maybe some of you get screwed up here because trigonometry, everybody freaks out. Easy. Easy. For shizzle easy, easy. Okay, so let's go to 31. This is also mega easy. Let me explain something to you. They want us to algebraically prove that x cubed plus 9 over x cubed plus 8 equals 1 plus 1 over x cubed plus 8. People start, oh, I know we can factor perfect cubes, and then what do I do with it? Stop. Let's not overcomplicate it. Let's try something simple first because it might work. I want to try and combine these two terms. I want them to be this. Okay? I want to end up with this. So let's look at the right side. In order to combine two terms, add or subtract them, and you're dealing with fractions, don't the denominators need to be the same? They do. I can't add 1 over 2 plus, 2 over 8 because the denominators are different. I can add them if I change 1 over 2 to 4 over 8 because that's a half as well. Now they're the same, and that's 6/8, which reduces to 3/4. That's the concept. So let's apply that basic concept that you learned in what? 4th grade, 3rd grade, whatever, right here. I want to change the number 1 so that it's a fraction with x cubed plus 8 on the bottom because I'm going to add 1 over x cubed plus 8. All right. What? Fraction. How do I make this equal to 1? Any fraction is equal to 1 as long as the numerator and denominator are the same. Anything over itself is 1. 5 over 5 is 1. 15 over 15 is 1. -15 over -15 is 1. -158 over 158 is 1. 158,322 over 158,322 is 1. I think you understand the point. I'm just being elaborate. As long as the top and bottom are the same, it's 1. So if the bottom here is x cubed plus 8, the top has to be x cubed plus 8. That is now equal to 1, okay? And this should be x cubed plus 9 over x cubed plus 8 when everything's all said and done. That was not a very difficult concept at all. At all. Now, I can combine my right side and make one fraction. So let's just carry this down. I have x cubed plus 9 over x cubed plus 8 equals. I can combine these into one fraction, x cubed plus 8. I take x cubed plus 8 and add it 1. What are the only two terms I can combine in this numerator? What's 8 and 1? Dang straight, it's 9. That equals x cubed plus 9 over x cubed plus 8. You proved it. Both sides are equal. And the only thing you had to do was convert your 1 into a fraction that had this denominator. So you put this over itself. That is it. We are done with 31. The 2-point problems are generally, you might not get them all, but out of the, I don't know, 6, I don't even know how many there are, you should be able to get 3, 4, maybe 5, I don't know, but you should be able to get those points. Don't leave them on the board, okay? We have one more video left, and that'll be part 5 of this June 2016 Regents exam series, I guess, and that will work on problems 32 through 37. I will see you then. Until then, have a good time, and don't stress out. Just keep working. You'll do fine. See ya.